Yes, this is an evolution of some things that we have been working on with the industrial data architecture at the city of Sabetha with the power and the water and the wastewater utility facilities. Long ago, there was a basic stopgap that was used for a for preventative maintenance. Very basic. There's not much there. Doesn't it's manual. It's 15 years ago Visual Basic. Not only is it a stopgap in the sense of the application that was homegrown, it's obsolete. It's been out of support for a long time. So this problem's persisted and I needed an answer for it. So that's what led to this. Basically, what we're going to do today is I'm going to show you the application that I built. It's not going to be long because it's replacing is simple, and we've enhanced beyond what that application is. It gives us something to move forward with. It doesn't have to be a stopgap. That won't take long. Then we're going to talk about the foundation because this application in a void would not be as good. The foundation with the AnyLog architecture matters. It matters for manageability. It matters for structure. It matters for scaling and taken to other places, which is something that's missed. And we're going to talk about how we built it. Last year or 6 months ago, I wouldn't have been to this point and agreed that this is a good idea, but it was. So this is a Base 44 app, as you can see. It manages the environment for us as long as we build it right. It isn't just a commercial, it's legit. And Claude is something I'm going to talk about. We used you're talking to Claude like it's a trusted advisor, an architect, not assuming you can go too far, but you're starting there and planning and then getting specific. Here's a basic dashboard to start with. This is going to be an iterative thing to get this the way that the customer wants. So we can see work orders here. We're going to be adding in a means of seeing and alerting on maintenance that's coming up that aren't work orders yet. That needs to be visible. We'll add that in. That becomes very minor work to do. This is basically a CMMS system, not building a major EAM competitor replacement, but a solid maintenance management. So asset, we have these are the assets, and there's tuning to do to categories, but these are the assets that are in Sabetha. We've got them entered. There are more. This is only what they asked for, so that's only what's here. And we have a schedule of preventative maintenance tasks that are necessary to keep track of, whether it's changing oil, changing filters, inspecting something. And there's a multitude of things you can do, calendar-based or based on runtime hours. There's some works in progress. The runtime hours, I need to have a PLC input that I don't currently have. We're going to be able to log runtime hours for how long since blower lube has been accomplished, or a calendar event that you need. There's means of doing other things if we bring in remote assets into the AnyLog data lake. We'll be able to monitor other assets as well, such as fleet if you want, and other remote devices and events. So there'll be means of a maintenance and overall operations view of things that you can take care of tasks and manage them from a supervisory basis rather than one computer hidden in a corner with a VB app on it. For example, let me open this one up. UV wiper maintenance. This is once every 30 days, and I can create a work order from here. Okay, I want this. This is easy enough. We're just going to make a run, and before the weekend, this is easy enough to do. I'm just going to make it tomorrow that it has to be done. All right, and I go to work orders, and here's my little. A lot of people call it a Kanban. It's a workflow of tasks. We see what's open, what's in progress, if something's on hold or it's completed here. You can select what it is you want to do. This one was, well, these are completed. Okay, so this one, let's say, okay, that's canceled. We're moving this forward in progress. That's a simple way to kind of view it as a supervisor and working with your team to see where you're at on work orders. Visibility on what is upcoming and will need to get into the system. That's a work in progress that we'll get so that you're not missing those things. This is really the fundamental reason why this was built. We went a little bit further. We have some dashboards we want to build and bring into here. This is a work in process as well. There's some other views that we're working on, but we can select one of these generators. This is real live data. This is a feeder, so we will get to see. This is manageable with Claude generated prompting, where really the teammate is your developer friend and expert assist is Claude helping you build a prompt for Base 44 to build out a dashboard and look at it. And we're talking to AnyLog through MCP, Model Context Protocol. And within AnyLog, we have a unified namespace structure. We don't have a broker. I'll want to throw that out to make sure that caveats there. We don't have a broker because we do not need one. We don't have an ERP, an enterprise asset management system separate from this, a warehouse management system. We don't have those other third parties to go between, but we do have a UNS structure, and it could blend into a UNS broker without any problem. And when I'm saying UNS, I mean a unified namespace that has been tabbed the name that is used to, it follows an ISA 95 structure. And the naming convention and bringing the context of data across systems together is what that's about. So we have the structure for this within AnyLog's Edge data lake, and we're talking to that with model control protocol from here. And that now sets you up for an architecture that goes multi-site, multi-area, multi-process line or cell, multi-unit, which is a device or a machine. And we can get to those this way. A little bit of a work in process here, but this would be an example. This is where you can drill down to the plant and to the data. It's not exactly where I want it to be, but we're getting there. Well, let me go a little further here. With Claude's help and iterations, these prompts are not 1 line or 5 lines. These prompts that we're building could be 50 lines, but it could be 500 lines, could be 200 lines. It depends. The initial was over 1,000, and it looked like code. It was very helpful, and it structured it well. It's understandable, and it was as if a software developer experienced was perfect with their pseudocode first before they started developing. That's what it looks like. Then it builds. So that's iteratively what we've done many different times with an agile methodology and good practices. So it's not just magic. You got to think like somebody who's a developer and think like somebody who uses good methodology and iterate like that. So you don't leave your skills at the door that are associated with that, but the development, the lookup of what's necessary for the syntax, great help. This is a bit new, so I'm not gonna pretend to show this off, but this is here because Shewhart control charts are the fundamental variance, normal variance versus special case anomaly tool. It's just meant to help find where we need to look. AI analysis, we have Claude embedded. So Claude using an API tool is embedded. I don't know, it's something like 2 to 3 cents per prompt, depends on what you ask it to do. And that's kind of behind the scenes. You're going to be able to have plenty of prompts in any given day for most people's purposes. You're not going to be running it all the time, but you can from here, I don't know, show me which generators have run this month. And it might be none because most of the time they're running off the grid. So this is a live, unprepared question. It's got to learn a little bit. We got to tune, and it's telling me where to go look. Okay. I'm learning what I want to do to ask this. So it's giving me some instructions of where to go look. I want to tune that up so it could just tell me. This is a inside, and it's just beginning to learn. So that will build over time. And so we now have, instead of Claude outside, which we have been doing and can do, going through MCP to talk to the city, AnyLog, this is now embedded in the app that talks to the city. And now we have a onboard Claude AI analysis assistant with us. We'll tune that up as we go. Reports are to be done thing, we have those. And to that point, Claude helps you build those too. So if you used to have Crystal reports and you don't have access, or you used to have Microsoft SQL Server and you don't have SSRS report access, you can build them yourself against whatever the foundational database is, doesn't matter. Some of these are just kind of behind the scenes admin settings. And for the power user developer, we have different configuration connection manager components behind the scenes. You can see we're talking to a particular address where the AnyLog database is talking to the database. We want to talk to a particular table and the namespace. Now, in this case, probably need to figure out the presentation of this because the smart city namespace gives me all three sites and anything within it. So I'm not actually limited to a table. That's the site. I'm going to show you underneath a little bit what we're talking to. So in the unified namespace in the smart city that I just mentioned, this is going through AnyLog's GUI and some more power user tools. You have the power plant, the water plant, the wastewater plant, and we can drill down in and we can see some assets. So the point is we can drill down in and we can see our data. And you can check. This is a good checkout location for testing and making sure you're lined up to the right tag in the PLC. You're seeing the right data. This, of course, drills down further as well. Let me close this out. Okay, so you say that I have this particular current. Let me make sure that that's what is correct and go looking with an engineer's help or on your own, depending on what screens you have, and do some verification. This is underneath the hood, how it's structured to get to your data. This is why it's architecturally scalable. As an edge data fabric, AnyLog is built to put together and extend to multi-sites, multi-process cells in an extension of the data lake that's very manageable. It's no code, or at the most very low code, to be able to do that. And it's not the same kind of a task challenge that old school legacy means of putting databases in would be, or going to the cloud and becoming a full stack architect that's setting up an enterprise. This is made as a technology underneath to do it. We have industrial PCs at each site. We also have Linode, I think it's a Kami Cloud or something like that now, where we rent virtual machines that are also a part of the Edge Data Lake. This is for multiple purposes, so you can extend and have high availability, redundancy, so you can have the master node controlling everything so that you can structure the query node the way you want it, and you can hit outside of the city. Nobody is direct accessing the city. It's secure behind the scenes going down into the plant via VPN monitored. That's the Edge Lake. You can extend that out as far as you want. That's structurally made to do that. The unified namespace OT data structure makes it organized and manageable and consistent, and that can extend across the sites as well. And that's another component that makes it extensible. And model context protocol changed the game of being able to tap it, not just from Claude as a remote AI, but also from within this application. Because after the application's built, that's not AI anymore. That's the application. There's AI components within it, but the application is using model context protocol as well. Certainly one of the standards moving forward. I have this was basically it. I wanted to talk about, the methodology with the AI is important, your structure, your architecture, the scalability, what the problem was we were solving to begin with, why we put together this application in its basics, and then extending it. I started out. How did I start out? I started out. This is noteworthy. I mind mapped in very substantial detail, and I basically got an agreement with Claude that that's a good idea. Then export it as an outline because it will give Claude a lot of clear instruction that can help you iterate with Claude to what it needs to build for a prompt for base 44. So that's how it all started, and then we went from there. And that's that's pretty much walked through everything I wanted to show. It's a progression of how to build an app, use AI, use best practices, use standards such as MCP, such as UNS, with the Edge Data Lake, with
Quick question at the edge of where you're running. What is the edge cloud operating environment, and who runs it?
so the edge environment is at the three plants. At the control level, the PLCs are Allen Bradley control logics, and that's where we're getting the data from. We're using Fusion, ICS 360 Fusion from a company called Dynix. It has a look and feel a little bit like Node-RED, but there's more to it. That's helping us flow the data to AnyLog from those PLCs. And then we used Lenovo SE30 industrial PCs with Linux on them, the Linux physically installed on the physical IPC that's sitting at each of the plants, one at each. Then using containerization, that's what, the environment really is for AnyLog. You're going to have Linux, you're going to have containers. So we have an operator node of AnyLog and a Fusion node on each of those industrial PCs. And that's where the data is collected. It stays there at the edge. It's not shifted. And then with a master node in the cloud and a query node of the edge lake in the cloud, we bring those together in a data lake and a metadata ontology, not an ISA 95 ontology for those that may care, but it is a one data lake, one database collective view of everything organized, structured, knows what it's looking at. And that metadata layer is what brings it together and keeps it very lightweight so that it can scale. This is a handful of nodes. And it's good to show that it can be this small. Add zeros behind that. A handful or 500 or 5,000 or 500,000 or more. These nodes scale as long as your edge nodes or your virtual machines in the cloud are spec'd correctly. The data lake itself, the metadata, and Moshe, Roy, anybody, correct me if I'm wrong. It's light and it extends. It doesn't really care if you're 5 nodes or 500,000 nodes.
Yeah.
It's fast. So that's what brings that up to the cloud, the edge cloud, together in the metadata of those edge nodes.
I want to add something on top of Michael's, just for clarification. I think Michael did a really good job in explaining it, but just to make sure, when John, you said edge cloud, there is no dependency at all on the cloud. It's only a question, where do you want to host nodes? And for whatever reasons, there are a few nodes on some distributed data centers, but there is no usage of cloud services. You could run everything at the edge. The master node, the blockchain emulator. So users have the option whether they want to use a real blockchain or they want to own the blockchain, and then it's an emulator. But if you're using the real blockchain, which is an option, then there is no central node. It's completely decentralized and the data is completely distributed and there is no dependency on the cloud, and you could just run nodes wherever you want. One more word about scaling. The whole concept here is that instead of pushing data to some centralized server, the data remains in place in those nodes. And if you don't get the scaling and the performance that you need, just add another node and another node. By adding more nodes, the distribution of the data increases. You've got less data on more node, and you are adding CPU and storage, and that's how it scales. It scales by horizontal scaling, and queries are now, if you add more nodes, are being satisfied by more nodes. You increase the degree of parallelism, and so you could tune the system to whatever performance that you need in a really simple way without making any changes to existing setups.
I would add that initially, when we did the original deployment, we did have the blockchain emulator and the query node running on one of the IPCs. But in in a subsequent redesign for reporting to go. It was easier to access that environment from a cloud than from an internal device. So when we did that redesign, we put the reporting node, the query node in the cloud, and added the master node or the blockchain emulator in the cloud. Again, not a cloud, but a cloud hosted node.
Dynex, who was the company or the group that actually provided that?
Right, that was the vendor we purchased that tool from. There's a multitude of things you could use there. OPC-UA could be one. There's a collection of industrial device and industrial protocol communications that is really solid, organized, and like a Node-RED sort of flow, you can control how it gets into AnyLog, and it's useful in that way. So that's what I happen to use, and I'm a promoter of it. That's one of many potential options to use.
What was the name of the company?
Dynex.
They also build industrial PCs, John. So they had a product that worked pretty easily to pull that data from Rockwell's native communications. There's a half a dozen other tools like Fusion out there that, as long as that tool can pull southbound data and push data to a REST API, we should be able to integrate with it. We're doing some work right now with Litmus Edge. I'm actually integrating it as we speak. There's Ori. You've done some work with another Edge tool out of LF-Edge. I'm trying to remember the name of it. EdgeX. Yeah, we've done some work with EdgeX. These are all middleware type of tools that talk southbound and then pushes data directly into AnyLog.
And I want to point out something here. Nothing we're talking about is really going to conflict with a major vendor standard that a plant and an end user has. You may, if you're Rockwell or you're Siemens or one of the other major, Schneider, Ignition, one of the other major vendors, you may not use Dynex because of that. You may or may not. It's irrelevant. The architecture we have with AnyLog, it really would be complementary to any of those things. They can use we have PostgreSQL as our database that we're storing data in.
Yep.
And I mean, it's solid, it's fast, it's open source, it's great. You could use InfluxDB. There's MongoDB these guys use for unstructured data and video. If somebody uses Timescale DB because they want to, great. If they have their own historian or database they want to use, that's fine. If they have their own connector to the PLCs and that they want to use instead of Dynex, that's fine. It would still work with those tools and then complement the collective control, HMI SCADA, and MES type environment. Any kind of environment that wants to go ISA 95 standard, unified namespace broker, the whole 9 yards. Sounds like they may be doing that with Litmus. Not sure, but it's complementary to all of that. And it's an edge data lake structure, keep the data in place, and a bit of a UNS hub at the same time. And all the standards apply. If you're a vertical of some kind, stay that way. This complements it.
What's interesting is because of the way we do UNS, Michael alluded to this, we push the UNS to each edge node. So data doesn't have to travel to get UNS relevance. We actually publish the UNS to the blockchain, and then that all of the nodes will get the UNS at the same time. The other interesting aspect about that is you can, even though it's not unified, but we have seen use cases to where multiple namespaces might be relevant for different personas that want to look at the same data. And we can publish multiple namespaces to that blockchain to describe the exact same data. So a different persona, an IT persona, can look at it in a unified way because they need to integrate data with other things, but an operator may want to look data in a different way because it's more relevant for what they are trying to do at the edge. Does that make sense?
Sure does.
To piggyback off of that, Mark, there is a difference between a UNS broker, which is going to bring all the context together. That, depending on how standardized you want to be, there may be just one version of that truth. But what you're talking about is really more of a UNS hub, and a UNS hub can have different structures that play by the rules with the broker. So I'm kind of in violent agreement with you on what you can do underneath of that. As long as you structure up with the broker, you can have different hub views or hub structures. That could be useful if you don't, for instance, want ISA 95. If in the transportation space you use a transportation management system or some other standard for what they do, you'll be a little bit fringe in connecting, but you can keep those few points of connection that matter and the standard separate, and look at that data the way that needs to be looked at.
I think that's great. Our own particular situation is with a gigantic manufacturing complex in which there are many companies, but they are all interrelated because the power and water management is unified for the complex. Even though each company, some fabricate metals, some fabricate materials, some gases, that sort of thing. So you can see that they want to be a separate data governance as far as what's going on, and yet some aspects are horizontal across all the different arrangements. So it's very similar to your city.
So having multiple namespaces will work wonders for you in that particular example, John. Each company can have their own namespace, and then you can have one namespace that kind of integrates the data from all the different companies. So that makes a lot of sense.
Yeah, super.
How easy was this overall?
I would say a month or less of getting there, and that includes the thinking, the designing, and the first run of doing it.
I think you're talking, though, just to make it clear, on the application side. I mean, on the data layer, there was nothing that needed to be done. I mean, that's
Right, correct. That was already in place.
Yeah.
But installing that, that's either days or weeks or an afternoon, depending on what it is. I guess it kind of depends. That installs pretty quickly, and that's seen in other presentations that have been made. So standing up that AnyLog architecture is not long.
John, we have a pre-built demo environment that runs on a VM for both EdgeLake or AnyLog. If you're interested, I can work with you to get that spun up. It's about a 10 gig download, but once you download the VM and run it in whatever virtual machine you want, VM service you want, then it's a pre-built environment. It's got all the components. You could start working and playing with it immediately.
Yep. I think that's great. Just for further edification here, when you talk about the environment that we are in, you have different process controls that are running. The one that runs the behind the meter power utility has it's an SEL type relative to the control of distribution of power. It's a little complicated because of the melting activities for titanium and the like. So it's not your simple home erector set as far as how the electric power is managed, because of how the harmonics and other elements come into play, especially as you're trying to keep them separate from anybody else that's in the complex. It uses Siemens relative to the continuous flow process controls in one company, but there are other tools in the other companies that are in the complex. So anyhow, it's a multi-tenant type of environment, but the solution here is going to be a holistic solution provided as a service for everybody.
Siemens is involved in the unified namespace arena as well. It's fairly new, but they probably have some solutions that would really like working with this.
Until we get through the assessment, we won't know the rest of the factors. There's a whole other chemical complex that we haven't entered yet, and they will have their own processes and things like that. And what we're finding is that unless you work as a team here, even though these are separate companies, you end up with problems that run into the hundreds of thousands of dollars or millions of dollars per incident that occur. So there's there's an aspect of team building here in addition to the technical aspects.
Right.
Important.
So John, one thing that you might want to look at is Mark demonstrated how we could calculate OEE in an industrial setup. Basically, it looks at what is going on into the process, energy and electricity, whatever is going into the process, what comes out, and was able to calculate how efficient, based on it, the process is, which is a very known standard in industrial space, and then be able to detect what are the factors that impact OEE on the process. We were able to do it using AnyLog setup that looked at, obviously, all the distributed data and the metadata, which was represented as a namespace giving an asset framework-like view of the data. And this was completely automated, and in minutes, we were able to show what are the prime factors that have an impact on the production or on a process. Fully automated, just pushing the raw data and into an AnyLog setup. And I think this is the type of things that you're looking at.
Yeah, that's why I put in the Sheward control chart, which I would prefer. I think the control charts are probably more complex than OEE. You can certainly use Claude or whatever to build those kinds of analytics.
Yep.
One of the things that you might be able to do, I think most of the SELs, or at least newer ones, support OPCUA natively.
Yes, they do.
Yeah, so we support in EdgeLake OPCUA natively as well. So you could just use that and pull directly in that interface. So in this demo setup that you can build, it will absolutely support OPCUAs. You could actually do a real quick and dirty test that connect up to one of the SELs and pull back some data, and you'll see it almost instantaneously.
Yeah, that would be great. Just so that you understand, this particular situation does not use the RTACs yet, which blows my mind.
They're using the protective relays?
Yeah, the protected relays and also the synchrophaser type of meter measurements for power quality.
Right. Yeah, so I don't think the relays actually support OPCUA. That's where you would have to use a product like Fusion, because Fusion can talk Modbus or DNP or one of the other supported protocols that the relays do have, and you could pull back data through something like Fusion.
Yeah. Now, in this particular case, the RTACs, once they implemented, are fine as far as any of those kinds of things, but they talk upwards to where we're going to be situating our own mechanism.
Perfect.
So not really responsible for pushing the red button and causing $1 million problem that
Yes.
that operates below us as far as what's going to happen. But this is all very fine. I got the picture. Got it.